In this video, I'm going to show how to create a dialog with a custom layout in Android using Kotlin. First of all, take a look at the app that we have so far, and you notice that there's an autocomplete text view. So I can start typing Eastern Redbud or something like that, and then I can select an item, in this case, Eastern White Pine. Now, watch what happens when I enter some text that does not exist in this autocomplete. As soon as I tab away, we get a toast that comes up that says enter a new plant. So what we want to do instead of having that toast is we want to have a dialog come up where the user can enter details about this plant. But with a dialog, the nice thing is we stay on this one screen, so we don't have to navigate to a new screen, which is one less click for the user, one less screen for us to write, and it helps keep the context of where the user is. So a few steps that we're going to need to do to accomplish this. First of all, we already have our app and we already have a Fragment class. The Fragment class is what handles all of the user interaction events with this screen. So in the file that contains that Fragment class, we're going to need to create a new class which extends DialogFragment, and we'll need to pass any values to that that are needed to render the dialog. Then we need to create a layout. The layout should contain all of the views or widgets, if you wish, like checkboxes or edit text or radio buttons or any kind of user input device that you need to collect information. And then after we've collected that information, we need to get that information back to the class that represents the fragment, and then that fragment can take some action based on the data collected. So let's jump right in. A bit of orientation. Mainfragment.kt is the fragment class that represents the screen that we're looking at here. It handles all the button clicks, it handles the autocomplete text view, the spinner, and everything else that you see here. Now remember there's an autocomplete text here at the top. I typed in Eastern or one of any of several other words, and you see that a collection or a list appears, and this happens to be a list of plant names. So each item in this list is represented by this plant KT, in other words, the plant data class. So take a look at the attributes genus, species, common, and then there's a unique ID. We could have some other attributes here, but essentially that's what's represented in this autocomplete, and that's the data that we want to collect when we pop up a dialog. So with that, let's start with our first step. Create a class that extends DialogFragment and accept any data required. I'll navigate towards the bottom of the Mainfragment class, and this is a good place to start our DialogFragment class. You'll notice that I have created a constructor parameter called enteredPlant, which is a string, and this is whatever the user has typed into that autocomplete text view. So this gives us an idea of where we are going to want to invoke this class. I can navigate up to the focus change listener for that autocomplete text view. That's what triggered the toast that I showed you earlier when I typed in Eastern Checkers Pine and it said need to create a new plant. So we can simply remove this toast and then say variable name new plant dialog fragment equals new plant dialog fragment. So there's our constructor call, and you notice that we're passing in something called enteredPlant. Now what's enteredPlant? That's whatever the user has typed into the autocomplete, which again in the example I used was Eastern Checkers Pine, a plant that does not exist. After that, we take this variable that's holding our plant dialog fragment and we show it, we pass in a fragment manager and do a null assertion on that, and then we just have to assign a tag to it, new plant. Just remember that this enteredPlant that we're passing in is the text that the user typed in. So with that, we can return back to our class, and of course, a lot more we need to do here. Let's look at the next step. Next step, create and assign a layout, which will contain the views or the widgets that will show to the user so that we can collect the data about the new plant. We're going to assume what the user typed in is the common name of the plant. So we'll have an edit text for that, and we're going to pre-populate that with that string that our constructor accepted from the autocomplete text view. We don't know the genus and species, so we'll have a couple of edit texts for that, and then we'll have a couple of buttons for when the user is finished with this plant. In the project view, let's navigate to App, Res, Layout. Then from here we can create a new layout file. New plant dialog will be just fine, and we'll leave the root at linear layout. Let's jump into the XML view and change the orientation. Since we just need 3 edit texts and maybe a couple other widgets, Linear layout's going to be a simple way to do this. Plain text, call that one EDT common, one more text, EDT genus, and one more EDT species. We'll go back to code view. That's just a lot faster, frankly. So the text attribute I don't really like because it puts text in there and then you have to delete it when you want to use this component. One that I like a lot better is hint, because that's like a label that's inside of that text box. The nice thing is, as soon as that text box gets focused, the label goes away. So the first one will say common name, although really that one is usually going to be replaced with the text that the user has entered in the autocomplete. Nonetheless, we'll go ahead and extract string resource. For genus, similar concept. And finally, species. Back to design view now, and you can see common name, genus, and species. And it looks like there's a bit of unused space here, but this is actually going to compress to only the size it needs to be when we create the dialog. So just make note of the name, new plant dialog. That gives us enough to continue writing our new plant DialogFragment class. Let's override the onCreateDialog function because that's what's actually going to create and return a dialog to our user. Careful, as there are several methods or functions that look very similar. We can remove the supercall because we're going to create our own dialog. Now, let's use a little bit of Kotlin magic here. First of all, we know that we need to return a dialog, correct? So let's say return activity $.let. Remember, let is one of our Kotlin scoped functions, so anything that happens inside of this curly is applying to this activity here. And inside of these curlies, where my cursor is now, we are going to create and build a new dialog and then return it, and that will satisfy our return condition here. But before I get too far, I want to consider what will happen if activity is null. Because note that I've used the question mark, which indicates that activity could be null, and if so, we'll want to put an Elvis operator after this activity let construction and throw illegal state exception. So if you're used to the Java way of doing things, this is a little bit backwards because this is essentially what happens if the activity is null. This is what happens if the activity is not null. But that's okay, that'll work for us. We now have both cases covered. Now you notice I still have a red line, and it's because I'm not returning a dialog just yet. So that's what we'll work on now. Just as we've done with previous dialogs, we'll start by creating a builder. Note that we're passing in the lambda variable, or the iteration variable there, it, which represents this fragment upon which we're calling the scope function let. So just a little connect the dots there in case that's not so obvious. Now this red line's going to bother me until it's gone, and the red line is just saying that we're under contract to return a dialog and we're not returning a dialog. So I'm going to go ahead and put in the last line of this scoped function now. Just with a footnote, there's going to be quite a bit that comes between the val builder line at the top and the line I'm about to enter. And with that, holy smokes, look, the red line's gone, and now we can continue. Next, we can do something with that layout that we just created. Get access to a layout inflator. Watch carefully what I pass to the inflate function. I pass a constant that's generated that represents that layout that we just created. Go ahead and save that to a variable because we're going to need that to get each of those components that we added to that layout. We'll use the findViewById function. This is something that we used a lot before Kotlin synthetics because we had to manually fetch items from layouts. All the views, all the buttons, all the widgets, all of those things we had to fetch with findViewById. I haven't found a good, easy way to use Kotlin synthetics when you're in a dialog fragment like this. So a lot of times I just go back and use the old-fashioned findViewById. We'll get our genus, species, and comments. I'll do a bit of copy and paste. Now that we have access to each of these edit texts, we can use them programmatically. In other words, we can set text in them, or we can get text from them. Now remember that this entered plant, which is passed in, is the text that the user entered into the original autocomplete, which kicked off this dialog fragment in the first place. And we want to use that as the default text that's going to appear in txt common. So let's do that. Next, we can set the view for this dialog. So you see several steps we've taken. We have our builder, which is building the dialog. We've created an inflator, and we have inflated the new plant dialog that we made just a few moments ago. Remember this thing with the common name, genus, species, so on and so forth. And now we've taken that common name, we've defaulted the text to it that the user entered, and now we've taken this whole view, which includes this view that we just created, this XML view, and we're saying that we want to associate this custom layout with the dialog we're about to create. Next, we want to set the positive and the negative button for this view. So there will essentially be a yes and a no button. We can do that right after the set view command just by appending another function to it. First of all, we have the text that's going to appear on the button, and that's a good thing to put in our string resource file. So I'll do an extract string resource. That way we can internationalize it a little bit better. Next, we need a click listener that represents the behavior we want to happen when the user clicks on the save button. So notice we're doing kind of like an inline lambda thing here, or an anonymous inner class if you're familiar with the Java paradigm. Nonetheless, once we're inside here, we can access each of these components we declared above where the user has entered some text. And then we can create a plant object out of that information. Now at this point we've retrieved the data that the user typed into each of these components. Let's take a look at our plant constructor, and you notice that it's expecting this in the order genus, and then species, and then common. The plant ID we have defaulted to 0, so we don't need to worry about filling that one out. Let's go ahead and create a new plant object. This looks good. We need to dismiss the dialog, and before we do that, we need to take this plant and hand it back to our enclosing class, which we'll do through a callback. Hold that thought for a moment. Let's go ahead and do the negative button, and then we'll come back and do that callback. But right now, we'll go ahead and dismiss this dialog. A simple get dialog cancel will work for that. Now, the negative button is quite straightforward, which is why I want to go ahead and take care of that now before doing anything else. So once again, we're going to give it the word cancel. We'll save that in our string resources. And then we need a click listener. In this case, because we're just canceling, all we need to do is get rid of that dialog. We can do that the same way we did it above in our positive button. And at this point, our dialog is coming along pretty well. Let's take a look at our next step. We've created the class that extends DialogFragment. We have a constructor that accepts any needed data. We have created a layout. We've assigned the layout to our DialogFragment. Remember that set view and all the magic we did with that? And then we have our views and our widgets that we've retrieved from our layout. Now we're on to the final part, which is the callback. This is a little bit tricky, but what we need to do is make an interface. Remember that an interface is a collection of function signatures. And any class that implements that interface must provide a definition for those function signatures. So we're going to create an interface. We'll have our Fragment activity class implement that interface. And then we're going to pass an instance of the Fragment activity class into this DialogFragment class that we've created. And that effectively gives us the ability to do a callback. I often talk about this like what you used to see in game shows back in the 70s and the 80s, before the internet happened. You'd see at the end of a game show like Price is Right, if you want to get tickets to Price is Right, send a self-addressed stamped envelope to this address in Hollywood, California. What that means is you would write an envelope addressed to yourself, fold it up, and you'd put that in a bigger envelope, and you'd mail the bigger envelope to the Price is Right in Hollywood, California. They would open up the bigger envelope, they'd find your envelope inside of that, they'd take tickets to the Price is Right, they would put that inside of your self-addressed stamped envelope, and they'd drop that envelope back in the mail, and then a few days, a few weeks later, you'd open the mail, you get the tickets back. That's how things worked back before we had the internet, believe it or not. Nonetheless, that's what I think a callback is. A callback is our opportunity to take our address, put it on a small envelope, fold it up, put that into a bigger envelope, and then the bigger envelope we send to the Price is Right, where in this case, instead of sending it to the Price is Right, we're sending it to our new plant DialogFragment. So it's coming from Mainfragment, we're sending it into our new plant DialogFragment. Quick note, I realize I'm getting a red line on this onClick listener because I mistakenly removed these two parameters. I'm just going to go ahead and put those back. Now we can take a look at our callback interface. I created a similar interface on a date dialog that I made in a previous video, right down here at the bottom of our file and outside of our Mainfragment class. So I can really just continue that same pattern. And you notice interface, we give it a name just like a class would have, and then we give it simply a function signature. Easy as that. Now let's add this interface type to our constructor signature for the new plant dialog fragment. And this is where interfaces are really powerful. We can use them as variable types. Now we can finalize our positive button. Before we cancel the dialog, we can say new plant created, receive plant, and pass in our plant object that we've created here. Actually, be a new plant object. Now, hang on just a moment though, because we've changed this constructor signature, right? So we also need to change the call to this constructor. We see that it's invoked here up on this onFocusChange listener, and you notice there's a red line. It's very subtle, but it says no value passed for new plant created. Okay, well gosh, what are we going to pass in there? We can't create an instance of an interface because an interface is just a contract. What we need to do is we need to implement the interface. So we need to think, who is interested in receiving this plant once it's created? Well, probably the class we're in, Mainfragment. So let's go up to Mainfragment and let's add this interface as another contract that Mainfragment has to implement. There we go. And in just a moment, we'll see Mainfragment will get a red line because it's going to say, hey, hang on a second. I'm implementing an interface, but I do not have the function that that interface has. I've not implemented that function. So Alt-Enter, implement members, and take a look, receive plant. Hopefully that looks familiar. That's the function that we've just created. And sure enough, there we go, receive plant. Okay, we'll come back to that in just a moment. Let's finish up that constructor call that we saw earlier where it has a little red line. So watch carefully. We're already passing in the text that the user entered into our autocomplete. Now we need to pass in something that implements the new plant created interface. And that something is the class that we're currently in. And we can refer to that with the this operator. So that's one really nice thing about interfaces and polymorphism is that the class we're currently in can either be considered a main fragment or it can be considered a diary fragment or a date selected object or a new plant created object. It can take the face of any of these types at any time because it either extends from that type, or it is that type, or it implements that interface type. Okay, all that being said, let's go back to our receive plant function. Okay, we have to decide what to do with our plant at this point, and really this is going to depend on what we want to do with it. We might want to save it to Room. And Room is the database local to the phone that's really ideal for populating autocompletes because a network call is not required. Additionally, with Room, we really just need to set up, guess what? An interface. I've already done that in a previous video, and this is a really nice thing about interfaces in Room, is that we don't have to worry about putting together a SQL statement. All we need to do is add yet another function signature to this existing DAO interface. I know it's kind of covered there, but we just add another signature to this and annotate it. Well, first give it the proper parameters and then simply annotate it with insert. Now we do need to do a bit more wiring than that because we need to pull it up through the plant service, and then from there we also need to pull it up through our application view model. So there's a bit more wiring we would need to do from that point. I'll pause for just a moment. I just added this new function to the plant service. You see it's a save function. The reason I'm fast forwarding through this is not directly related to the dialog. I just want to show this for a complete loop. So save plant, it's getting the plant DAO and it's invoking save. And from there we can go to our application view model. No changes needed here actually. This one looks pretty straightforward. Back to our main fragment now. We've already instantiated the application view model. We did that a while ago. Then we get our plant service and then save plant. And snap a breakpoint there so we can watch it. I'll snap a breakpoint on several of the other places that we want to look at in the debugger. Once again, you might not be using Room or live data or something like that. So what you're doing here might be different from mine, but just make note, this receive plant the user has entered the plant data in our dialog fragment, we've received it, and now we want to do something with it. In my case, it's saved to room. Your case might be different. Let's take a look. We start with Eastern Redbud. Everything's fine. I can choose Eastern Hemlock. Once again, nothing changes, but let's change to our special plant, Eastern Checkers Pine, which is just a made-up plant. I tab away and notice that when I'm in the if test here, we capture the text that I've entered. Let's mouse over entered plant and we'll see Eastern Checkers Pine, and that's a new plant. So at this point, it's going to construct a new plant dialog. I'll go ahead and choose F9, and here's our DialogBuilder. So we inflate the dialog layout, we get access to each of those views, and notice that we are pre-populating the common with the text that the user entered. Now we set our view, and we configure the positive and negative buttons. I click F9, quickly come over here, and you see that sure enough, common is populated with Eastern Checkers Pine. Now, funny enough, if I were to delete Eastern Checkers Pine, you see that hint common name would appear until I start typing again, Eastern Checkers Pine. Genus, Pinus. Species, Checkers. Just making that up. Now I'm going to choose Save, which is the affirmative button, and watch what happens here. You notice as soon as I hit Save, it grabs the common name, should still be Eastern Checkers Pine. It grabs the genus, Pinus, and the species, we said Checkers. And now it is generating a new plant from that, and it is going to our new plant created callback. Watch carefully as I press F7. And notice that this goes to our callback method, and this is where we're going to save this into our local room database. I'll go ahead and press F9 and allow that to continue. Now I realize that I have a threading issue there because an exception appeared, but nonetheless you get the idea. That's where save's going to happen. So I'll tell you what I'll do is I'm going to restart this and I'm going to turn off breakpoints so that we can just watch this happen a little bit faster. But nonetheless, you did see there that the callback is calling back to this method on our main fragment class. And that's where I say do whatever you want. I could clean that up with coroutines, but that would be another 5 minutes in the video. And at this point, I'm satisfied that we've seen the callback working. So I'll just comment it out and redeploy. So here we are again, Eastern Checkers Pine. Tab away. Dialog box comes up, Eastern Checkers Pine, Pinus, Checkers. And then we choose Save, and we know I've disabled that callback, but nonetheless, we see that the dialog box goes away. Once again, I click up in there and I get the box again, and this time I could just choose cancel. What happens on a cancel? The box goes away and the callback is not saved. Well, I know that was a long story and I appreciate you sticking with me through it. Creating a dialog with a custom layout is a very effective way, in my opinion, to help keep your app simple with a limited number of screens, opposed to the way where we used to do it, where we would have some search text, then we would see results, then we would enter something new, and then we would have a confirmation screen. You see, if we think of those all as different screens, we end up with a very complicated flow, and that's more cognitive overload for our users. So as always, I hope this video was helpful, and I look forward to reading your comments. Thank you.